All right, now we're jumping into chapter 7. So the law of sines. The laws of sine and cosines, which we'll see in section 2, are both really kind of fun things that we get to do where we can find missing pieces of triangles. So I don't know, I just like this stuff. I think it's really fun. So let's just consider a basic triangle. This one happens to be an obtuse triangle, but it really doesn't matter. It's got angles A, B, and C, and then sides A, B, and C. And the really important thing here to notice and to pay attention to and remember is that they are labeled opposite of each other. So angle A and side A are across the triangle from each other. Same thing with the B's and the C's. And that's always going to be the case when we do this because, well, for a reason it's going to become clear in just a second. We always have these sides and angles paired up across the triangle from each other. And so that's really important. So here at the bottom, I have the law of sines. Little a over the sine of capital A is equal to little b over the sine of capital B is equal to little c over the sine of capital C. And you're never going to use all three fractions all at once. Okay? You might use them all in one problem, but you won't use them all at once. So when we do the law of sines, here's what we're looking for. In order to use it, we have to have three pieces of the triangle, okay? Because you have to have one whole fraction and another part of a fraction to be able to solve for anything. If you only have two pieces of the triangle, you can't set up an equation that you can solve with only one missing piece. So you have to have at least three pieces, and you have to have a pair. So you either have to have both A's, both B's, or both C's to make it work. And again, as we'll see, that's because, for instance, if we want to try and use these two, A over sine A and B over sine B, we can only have one piece missing. And so we need one complete fraction and then part of the other one in order to actually solve for something. So over here on the other side of the board, I have an example. We have a triangle. I've labeled two different angles and one side. So hopefully you can read it, but we have C up at the top is 125 degrees. Capital B, the angle is 25. Sorry, C is 125. Capital B is 25 degrees. And then across the triangle, the side B is 5. So normally in a problem like this, we try and find all three missing pieces, but pay attention to the directions. You won't always be asked to find them all. I'm going to find two of the pieces because honestly I ran out of room, and the third one works exactly the same as the second one. So anyway, here we go. First off, I have two angles, so the third angle is really straightforward. There are always 180 degrees in a triangle, so I just subtract. Take 180, I subtract the two angles that I have, the 125 and 25. Angle A has to be 30 degrees. That one's done. So that's really nice. If you have two angles, find that third angle first. It'll always be a good place to start. All right, so that just leaves the two sides, side A and side C. So I'm going to go ahead and find side A, and I'm going to leave it to you guys to find side C. Here's a hint. It's going to work basically exactly the same way. So if I want side A, that means when I consider my fractions here that are all equal to each other, I need the fraction that has the A's in it. So that's why I have little a over the sine of 30, because remember we found capital A and it's 30. So now I have to pick the other fraction that I want to use. So I can't use the C's because that would give me another thing I don't know. Right? We don't know side C yet. So I'm going to choose the B's. So I have side B is 5 and angle B is 25. And so I have that fraction. So then the way to make this work is we're going to cross multiply. And I'm using a red marker there, but you guys probably can't see that. But anyway, there you go. So I cross multiply. So we have A times the sine of 25 is equal to 5 times the sine of 30. I want the A by itself, so I divide both sides by the sine of 25. And that gets me this mess. And now it just goes in your calculator. Be really, really careful. Remember, your calculator has two modes, radians and degrees. These problems will always be in degrees, so please make sure they are calculators in degrees. The other thing to watch out for, your calculator will give you parentheses. So make sure you close them. And when in doubt, and you probably should, just throw an extra set of parentheses, at least around the numerator here, to make it work. Just be careful. Absolutely make sure you're in degrees. And there we go. There's side A. It's 5.9. And side C we would find the same way, but instead of using the a fraction, we would choose the c fraction. We'd have c over the sine of 125, and then the process would look exactly the same. All right, we'll do a couple more.